Hello after the break. So now we have time to go through the remaining trade models that we have for today. And we start with the Heckscher-Ohlin model, which was developed by two Swedish economists in the beginning of 20th century. Before jumping into this model, let me first summarize the main assumptions of the two previous models. So we had a Ricardian model of trade in which we had two countries, we had two goods, but we had one factor of production. It was only labor that produced both goods in both sectors. Then we have the specific factors model, in which, technically speaking, we had one country, but we had, once again, the two goods. But to produce two goods, we had three different factors of production. Two of them were specific, capital and land, and one of them, labor, was mobile across the two sectors. Here in the Heckscher-Ohlin model, we will consider two countries, two different countries, two sectors, which mean two different goods, and two factors of production. So that we can say that the structure of the model is similar to the specific factors model, but we have two economies now and two factors of production, both of them being mobile, let's say capital and labor. So what is important in terms of the Heckscher-Ohlin model is that the trade, the motivation for international trade is simply the difference in allocation of resources across the two countries. And this is the only way that the gains international exchange in goods in the Heckscher-Ohlin model. So my goal here is not to show you that the full model, which has been already developed years before and extended in the literature, even though it's not the model of the international trade that is used nowadays in terms of predicting the effects of different trade policies. My goal here is just to give you the brief summary of the main conclusions and the main intuitions of the model. So once again, in this type of trade model, we will have trade which is motivated by comparative advantage. But the comparative advantage between countries is now determined by nations' resources or the allocation of those two factors of production across countries, relative abundance or relative scarcity of factors, not by the technology of production. As you remember, the technology of production was the motivation for comparative advantage in the Ricardian model. Yeah. So there countries we had this matrix of the labor inputs for both countries and for both goods, and countries which had comparative advantage in the technology of production of goods had traded those goods on the international goods market. Now, in the Heckscher-Ohlin model, we assume that countries have identical technologies. Of course, this is a very simplifying and an assumption that makes no real life sense. The aim of this is to simply tell you that even if countries had same technologies, there will still be scope for international trade, gains from international trade due to comparative advantage. How this comparative advantage will evolve in the will appear in the Heckscher-Ohlin model? Well, through the fact that you have an equal assignment, an equal supply of different factors of production across countries. For example, take China. In which factor of production China is relatively abundant comparing to all the other countries in the world? Well, you know it very well. China has relatively huge supply of, let's say, labor, low-skilled labor, yeah, in general. Therefore, low-skilled labor in China is said to be quite cheap, and that is what makes China being the biggest exporter in the world. The fact that they can produce a lot of goods using this input, which is relatively cheap in China, which gives them a comparative advantage in terms of cost of production of different goods. Hmm? And this is exactly how the Heckscher-Ohlin model works and how it predicts the economy, the global economy to work. Due to the fact that countries have relatively different allocation of resources, different supplies of resources, this gives a source of comparative advantage. The first element of the outcomes of the Heckscher-Ohlin model comes from the so-called Rybczynski effect, which tells us that countries which are relatively abundant in a particular factor are more productive in producing goods that are intensive in these factors. Once again, taking the example of China, China is relatively more productive in those goods that use low-skilled labor as the main input. Say, all the easy, simple electronics, um, clothes, for example, and all the other simple goods that they are exporting all over the world. And this is a natural implication of the fact that this particular resource in China, low skilled labor, is abundant, is in big supply. That is why its relative price is low, right? So this is the first element that motivates the main result of the Heckscher and Ohlin, summarized by this theorem. The country that is abundant in a particular factor exports the goods whose production is intensive in that factor. As simple as this. China is exporting those goods that are intensive in low-skilled labor. At least it was the case in the last years. Now China is developing very rapidly and is investing a lot in new technologies. And I will not be surprised if in 1 decade or in 2 decades, China will overtake all the other countries in terms of technology-intensive goods, which is already taking place, with all those Huawei mobile phones and all of those really advanced goods that they are producing. But to make a point, low skilled labor intensive goods were those goods in which China had comparative advantage in in the last years. And this is how our intuition works. This is what we know from the historical data. And now some additional consequences of this theorem, of this trade model, very similar to the ones that we saw in the specific factors model. The fact that owners of a country's abundant factor gain from trade, but owners of a country's scarce factor lose. And this is exactly the same as we observed in the Samuelson model of specific factors. Okay, but now remember that here in the Heckscher-Ohlin model, there are no specific factors, right? All the factors are mobile across sectors, which means that even though there are no specific factors, still the abundant factors gain in the country while the scarce factors lose. In the long run, the Heckscher-Ohlin theory predicts that all factor prices equalize. This is a direct consequence of the assumption that the technology level in all the countries is identical, which is a big simplification. We know it, all right? And once again, well, if we know it, and if we know it that this is not the case, is it a reasonable prediction from the Heckscher-Ohlin model in the long run all factor prices equalize? Of course not. We know that this is not the case. That is why a Heckscher-Ohlin model is something that is a model that is really on the decrease nowadays. Some examples of no equalization of factor prices across countries. Very simple. Take wages across countries. They are not equalizing at all. Take even the returns to capital across countries. They are different as well. There are countries with high returns to capital, the developing countries. There are countries with low returns to capital, the developed countries. And there is no convergence in terms of returns to capital, even though capital is relatively way more mobile across countries than labor is, right? One interesting fact that came out of the Heckscher-Ohlin model, which was kind of surprising for the economists at the time, and I mean here the late 1950s or the period after the Second World War. There was an economist, Valery Leontiev, who formulated a paradox relative to exactly this Heckscher-Ohlin theorem, which to some extent started to falsify this theory. But what appears to be the reason of the existence of this paradox is in fact the definition of those factors of production that we are talking about, and we are not actually formalizing or defining what those factors of production mean. So let me introduce you to the Leontiev paradox. So in the 1950s and 1960s, according to the Heckscher-Ohlin theorem, the United States should export goods which were capital intensive, because the United States at that time, as it is right now as well, were relatively abundant in capital in this factor of production, right? So according to Heckscher-Ohlin theorem, this should be the structure of exports. Moreover, the US should also import labor-intensive goods, as it was relatively scarce in terms of labor in general. And actually, the Polish-US economist Leontiev found out that this was not the case with the actual data of the US trade structure in the 25 years after the World War II. And economists started to think maybe this model is total bullshit, and it means that the assumptions of this model are totally false. So there were people that were trying to explain the source of this Leontief paradox. For example, um, some attributed those results of Leontief to some specific effects to the time period considered. Cheap talk, not that interesting from the economic perspective. Others thought that, of course, the assumption of common technologies used by United States and other countries in the world is a very strong and not a really um, meaningful assumption, and this is, of course, the case. But then you have a Heckscher-Ohlin model with technology differences across countries, and it predicts exactly the same, the same pattern of trade, and it's still in contrast with those findings of Leontief. So once again, not a good explanation of the paradox. But there is a good explanation for the paradox. Maybe the United States is exporting goods that heavily uses skilled labor, innovation, entrepreneurship, while it imports those goods which are, heavy manufacturers goods, cars, for example, which use large amounts of capital, which means that, well, maybe the factors of production that we are thinking about in terms of the production function are not exactly as precise as we should do it to be able to properly describe international trade patterns. Maybe just dividing factors into labor and capital is not enough. Maybe there are different types of labor, and this is actually the case. This is what this explanation tells you. There are different types of labor: low-skilled labor, high-skilled labor, researchers, scientists, which produce innovations. You have also entrepreneurs, the guys who are running the business, who are making, the business going forward, increasing the profitability of companies. Managers, for example. These are the things that are absent from, all of those trade models that we were talking about for the moment. That is why what was exported from the US was, well, relatively labor intensive, but it was intensive in high-skilled labor. It was intensive in scientists and innovation and entrepreneurship, inputs of entrepreneurship, not in low-skilled labor. What was imported to the US was, well, actually goods that were intensive in capital, like cars. Fair enough. It still works with the Heckscher-Ohlin model. Conclusion: this Leontief paradox gives us a broader view on what determines the patterns of international trade. Within the framework of Heckscher and Ohlin model, what we have to realize is that countries are endowed with different types of production factors, and the endowment of production factors, of course, matters. While the US is well endowed in high-skilled workers and scientists, China was used to be well endowed in low-skilled labor. I know Japan, Korea is well endowed with capital. That is why those countries are trading and exporting those goods in which they are relatively goods which use factors in which those countries are relatively more abundant, and this gives them the comparative advantage in exporting those goods because the relative prices of those particular factors are cheap, are lower. So once again, we go beyond the standard capital labor division in interpreting this Leontief paradox. All right, so now let's have a very short discussion, or my own monologue, okay, about what is the comparative advantage of those three countries we have over here, and in which resources, in which factors of production those countries are abundant. Qatar, United States, China. So I guess we all have a very broad and well rooted expectation what we expect here in terms of the abundance in terms of the abundance of factors of production. Qatar, of course, the Gulf country with a lot of oil in the soil. That is why the factor of production they have, or in fact the intermediate good they have, yeah, is our natural resources. Yeah? One of the particular factors of production. United States, as we mentioned before, high-skilled labor. China, as we mentioned before, low-skilled labor. But as I told you, it changes very rapidly, and in 1 or 2 decades, I'm really expecting China to be the main leader in terms of innovation, in terms of those advanced goods as well. All right, so let's analyze the export structure of those three countries, and we start with Qatar. So here what you have is a rectangle which represents the 100% of exports from Qatar by types of product. And those small surfaces of this rectangle represent products of different type. So for example, we have fuels, we have different other categories of goods that are exported, which are not directly classified. We have minerals and some other stuff, which is really tiny out there. So we see what's the export structure of Qatar. It's 81.5% of fuels, of things that are really intensive in the factor in which Qatar is abundant, oil. Fair enough, in line with the Heckscher-Ohlin model. We go to the next country, the United States. There you see a bit more diversity in terms of what the United States is exporting. You have machines and electronic devices. You have those different other goods that are not classified. You have chemicals, transportation, fuels, vegetables, metals, plastic, rubber, all the other goods as well. In general, all of those goods here are very high skilled intensive. They are capital intensive, high skill intensive, innovation intensive, and that is what the US is actually exporting to other countries. Fair enough, in line with Heckscher-Ohlin theory. And what about China? Well, in China, this structure is also very interesting. You have 40% of machines and electronic devices. Now the question is, what is the actual comparison between those machines produced and electronic devices produced in China and those produced in the United States? To have a clearer view about this, well, you need to go really into detailed product categories. But once again, for the moment, we believe that these are a little bit less technologically advanced products. You have textiles, clothing, you have metals, chemicals, and all the other categories. Some of them, especially textiles and clothing, and some of those electronic devices are low skill intensive. The factor in which China is kind of well endowed. But of course, these high-skilled branches of the Chinese economy are flourishing at the moment, and you observe that some other goods that are high-skill intensive, like transportation, cars, for example, are also becoming more popular in the structure of Chinese export. If you want to have more detailed information on the structure of international trade by country or by product, you are really encouraged to visit this website, where you have a lot of data, a lot of ways of depicting those data in a very nice graphic ways. Fair enough, if you're interested in this. Okay, so to sum up the Heckscher-Ohlin model, the difference between the Heckscher-Ohlin comparative advantage and the Ricardian comparative advantage is that in the Ricardian model, the comparative advantage was 100% due to the difference in technologies, while in the Heckscher-Ohlin model, we keep technologies constant or identical across countries, right? And the source of comparative advantage is the difference in the allocation of resources. The fact that China has a lot of low-skilled workers, US has a lot of high-skilled workers, or Japan has a lot of capital. And that is why those countries are exporting those goods which are intensive in those factors. Okay, fantastic. So we are ready to go to the last A source of international trade, last motivation for international trade that we have out there, which has been developed by the famous macroeconomist Paul Krugman from the New York University, the, the guy who is one of the most influential trade economists and economic geographer uh, of our times, awarded the Nobel Prize in Economic Sciences, and he is especially famous for his fundamental contribution to the theory of industrial organization, including the theory of economies of scale, consumer preferences, and diverse goods services as main motives for international trade. This is what Paul Krugman, with individually but also with some other co-authors, really brought significantly to the literature. So let us go through a very simplified version of the Krugman model of the economy, and let's try to derive the model to give you the insights about what are the other motives for international trade, apart from comparative advantage, apart from technology, and apart from the allocation of resources. Huh? There's still something that we have to mention in this respect. All right, so a short introduction into the Krugman's world of economy. Some industries are prone to concentration, and you know this from your micro class that there are things which we call oligopolies or monopolies. Some industries, for example, those that have barriers to enter the market, are very concentrated, are represented by one particular company which serves very many markets. And this is the source of economies of scale at some point, but also a source of monopolist pricing of the product, which is something which is inefficient, as you know, from your micro class. Then let's discuss what features would make the monopoly to arise. And this is a short repetition from your microeconomics class. Of course, barriers to enter the market. For example, the technological barriers. So the fact that there are some products which you can produce, but you have to have a very advanced technology to produce them. For example, SpaceX of Elon Musk, the guy who is actually who is making money off on absolutely everything he touches. But in SpaceX, they are producing, rockets to go to space. Very specific technology, very constrained in terms of entering. The same with electric cars, but this is becoming a bit more widespread as this technology is really something that firms, governments, and people as well are hoping to flourish in the next decades. Then there is an exclusive technology of production. Yeah, exactly. So this, to some extent, copies my example from the first point. So maybe a better example of the barriers to enter the market could be some legal barriers to enter the market, like the fact that you have to have a state permission to run your business. Like, for example, mines or gold mines, coal mines. Well, you just cannot set up your mine. You have to have a permission to do it, right? So my example with the rockets and electric cars fits better to the second point. Then the third point, why monopoly can arise in the economy? Well, the goods that are produced by a particular company are unique. And this is a disputable thing, whether some goods are unique, others are not. Some think that Coca-Cola is a unique good, others think that it's not. Some think that an iPhone is a unique good, others think that this is not the case. So, it slightly touches this preference channel, which we would like to discuss about in this particular Krugman's model as well. And I will come back to this in just a couple of minutes. The fact that people perceive some goods to be unique. Then the resources are exclusive. Once again, my example of coal mining is maybe fits better to this particular point. I don't want to go back to the barriers to enter the market to explain. I hope that you have a good feeling about this particular bullet point. And then the last thing, if there are economies of scale, decreasing unit cost of larger volumes of production. And the best example here are those industries which really require huge fixed cost initial investments to enter the production sector. Example, well, the whole energy sector. To run your own nuclear energy plant, you need to invest a few billions of euro to start producing. And this is a huge fixed cost that you have to put into the into your business, which has to be somehow covered by the sales that you then offer to your customers, right? Which means that the economies of scale is the fundamental um, feature, the fundamental characteristic of some businesses that causes concentration of those businesses, right? So what about this cost story and this decreasing unit cost for large volumes of production? Let us write down a very simple model in which we just write down some cost and revenue functions for the enterprise. Let's assume that in the firm or in the economy in general, total costs are and revenues are given by those two functions. So costs are a sum of the fixed cost part, this small f, and the variable costs, so W being the unit variable cost, and X being the amount of number of goods produced in the company. Okay, we have variable cost, which is increasing with the volume of production and the fixed cost of production. Then revenue is of course the price of the goods times the number of goods that you are selling on the market. Total profit is of course the difference between the two things that we described above, which if you do some simple algebra, this is the difference between the price and the unit variable cost times the number of goods that you are selling minus the fixed cost of production. So what this gives us in a very simple example, the unit cost of production then, that is the total cost divided by the number of goods that you sell, is the unit variable cost plus the fixed cost divided by the number of goods that you produce. What does it mean? It means that if you have big scale of your business, then if you increase the sales of your business, the actual unit cost is decreasing, right? Due to the fact that this fixed cost is divided by the number of units that you sell is a decreasing function of X. Similar thing happens with the unit profit. So the profit per unit of goods sold. This is now an increasing function of the number of units that you are selling on the market. Even though P minus W is a constant thing, you are subtracting something which is decreasing in the number of units that you sell, the fixed cost over the units, which means that the higher number of units that you sell, the higher unit profit. And this is exactly why how the scale of operation of firms translates into very simple economic or corporate finance language. All right, and this particular source, this decreasing unit costs with the volume of production and increasing unit profit with the value with the scale of production, gives us a very good ground for defining something which is called a monopolistically competitive market. Monopolistic competition, hopefully you are familiar with this model from your microeconomics class, but let us summarize very briefly this particular way of describing the economic, the production process, the industrial organization in general, which is the base for the Krugman model. So what are the assumptions of the monopolistic competition model? Firms are assumed to be local monopolies, which means they produce differentiated goods. What does it mean? Well, it means that consumers can to some extent differentiate one good from another and say that, well, goods are to some extent different, which means I would like to consume a bit of one good and a bit of second good. This relates to some extent to one of our causes of monopolies. The fact that good produced by firms is unique. Maybe to some extent people think that goods are actually unique, and this gives firms a bit of local monopolies power. Within producing this particular variety or type of good, the firm can act as a monopoly because this good is slightly different than any other good that is sold on the market. All right? And we assume that one firm is producing one product variety or product type, if you like to call it like this. Then there are buyers to enter the market. In a way of, expressing this as a fixed cost of entry, as we did in our very simple computation over here. So to start production, you have to pay the fixed cost of entry. Then producers can freely enter the market. So even though there are barriers to enter, there are no legal or formal constraints for firms to enter the market, which means that if you pay the fixed cost of production, the fixed cost of entry, you are free to start your production. Okay, so there is no, let's say, legal constraint on the market. And then there are infinitely many producers, or in general, many producers, so that this model to some extent resembles the perfect competition model. As you know from your micro class, this is a merger of a monopolistic model, because firms are local monopolies with differentiated goods, and perfect competition model. You have free entry for the market and really many producers. Yeah, but this is not neither a monopoly nor a perfect competition. This is a mix of the two. And the last thing that we assume about the monopolistic competition model is that firms are indeed monopolies, local monopolies, in the sense that they observe individual demand functions. They know what is the relation between the quantity of the good that they are selling and the price of the good that they can sell. Sorry. So firms know the exact reaction of individuals to different prices they set on the market. Okay, so the relation between price and goods, or the sales of the company, is known by the producer. And this gives additional monopolistic power to those firms. Okay, so now we are going to write down the equations of the Krugman's model, okay, which is a simple monopolistic competition model. So what we have here is that one of the important innovations of the Krugman model, that is formalizing this first bullet point we have over here, the fact that firms are local monopolies and the products are differentiated. You can write this down in an equation using a particular utility function of an individual. So we assume that the utility of every individual is the sum of the individual utilities of consuming each of the goods I, and I is indexed from 1 to n. So this is the discrete type of the Krugman's model, if we assume that there are many goods or many firms in the model, but they are discrete. But if you go to infinity with 1 over n, so you assume that each and every producer is infinitesimally small, well, this gives us, the continuum version of the model, in which the discrete sum is substituted with the continuous integral. And this simplifies math a bit, so I will now say everything in terms of this continuous model of Krugman. But this is exactly the same. So the total utility is the sum of utilities that you gain from consuming each and every variety of the consumption good. And we sum it over all the n varieties which are available in the country, all right? And we assume a standard thing that the utility function is an increasing function and it's strictly concave, which means that there are decreasing marginal utilities from consuming the good, which making a bridge, very long bridge to what we talked about in the previous part of this lecture, decreasing marginal utility of consumption, which is equivalent to a decreasing marginal productivity of some goods in the specific factors model. Okay, I hope that you are familiar with those two, with linking those two things together. All right, so individuals maximize this utility subject to a standard budget constraint, which tells you that whatever you spend on the goods that you want to buy, which is the sum of products of prices and quantities, has to be smaller than the wage that you earn. And in the continuous form, it's simply like this. All right, so standard micro one problem of utility maximization subject to a standard budget constraint. One important thing, we need one more detail about this small utility function, which is assigned to each and every variety of the consumption good. We assume that this function is a power function, so it's xi power theta. This is a Greek letter, which is a parameter of the model. And we assume that this theta parameter is between 0 and 1. And you will see in a couple of minutes that this is a fundamental parameter of the model, of the Krugman's model. Before jumping into solving the model, let us first see what is the reaction, what's the difference in terms of the utility function when we do some manipulation of this theta parameter. So when theta goes to 1, of course, the utility function becomes very similar to the linear function. In fact, what you can observe is that the utility function, if you draw it in a way that you have here x on the x-axis, and here the utility of x on the y-axis, well, if theta is very close to 1, this means that we have the function x power something close to 1. We are very close to the straight line. This is true if theta is really is close to 1 in general. You see that if we decrease the value of theta, what happens to the utility function is that it becomes concave. The smaller the theta, the more concave the utility function becomes. Why is this important? On the one hand, this means that consuming a larger amount of one particular good does not bring you that many marginal incremental utility. And this is due to the fact that the utility function is becoming very strictly concave, right? Comparing to the almost linear case of large theta, when each increment of consuming the same variety of good gives you the same increments in utility, which simply means that the change in x over the change in utility over the change in x is constant, almost constant across the axis, right? The first derivative is almost constant and equal to 1. Here it's not the case. You see that if you consume the particular variety of a consumption good in small quantities, you have a very high increase in the total utility. Then if you start to consume, for example, from 1 unit to 1.5 units, your increment of utility is relatively small. And this becomes even more severe if you decrease theta even more. The change in the utility in consuming very small, going from 0 to, let's say, 0.1 units of consumption of the variety gives you something like 0.6 change in the utility. So you go from 0 to 1, you increase your utility from 0 to 0.6. But then if you increase your utility from 1.5 to 1.6, for example, so the same increment that we had over here, well, the change in your utility is almost not important. Okay, and if you go to the other extreme, what you get is that your utility function is almost a line that is reaching the maximal value almost exactly when you consume a very small proportion of one particular variety. What does it mean in our Krugman's model? It means that when theta is close to 1, then when the utility function is almost linear, then there is a very big substitution across different varieties of the consumption good, which means that this property of uniqueness of the goods produced by different firms, by different monopolistically competitive firms, is not very strong. Due to the fact that the goods are very close substitute to each other, this uniqueness of the product is not a very strong feature of the market, which means that in fact we are very close to perfect competition. Firms are not local monopolies, don't have very large monopolistic power when theta is close to 1. And vice versa when theta goes to 0. When theta goes to 0, you saw in the graph, the utility function becomes very strictly concave, and it means that there are huge effects of this uniqueness of the good. There is very small substitutability of the goods. In fact, the goods become complements between each other. You need to consume each and every variety of the individual, each and every variety of the consumption good to increase your utility. If you consume only one variety, well, you will not get a high utility because your increments, when increasing the consumption of one particular variety, the increments of your utility are very, very small. Which means that if theta goes to 0, then consumers prefer to consume all the varieties of the consumption good, but in small proportions. While when theta is close to 1, people don't care. They can either consume all the varieties, they can consume only part of varieties, but in large quantities, it doesn't matter, okay? Cool. So hopefully you get this intuition of this love for variety or love of variety effect that we are talking about here. If theta is close to 1, there is no love of variety. People like to consume whatever. If theta is close to 0, this means that there is a very small substitution across different goods, and people really love the variety, different types of consumption. So now let's try to derive the Krugman's model, the simplified Krugman's model. So for this, I have some um, traditional Microsoft Word stuff prepared. So first of all, let's talk about consumers' decisions about consumption. So what is important here is I will give you some hints how to solve the model, but you have to solve it on your own with, pencil and paper so that you are sure that you know how the Krugman's model works. Okay? So the consumer's decisions about consumption. So of course, consumers maximize the utility function, which we had over here, and they maximize it with respect to xi. So everyone chooses the actual bundle of different varieties of goods that they want to produce, that they want to consume, knowing the theta parameter and knowing that they have a particular budget constraint. And you know from your microeconomics classes how to solve this problem. You simply write down the Lagrangian. So you have the utility that you are maximizing minus lambda, which is the shadow price of the of your income times the difference times the constraint that with respect to which you are maximizing your utility function. And you have to compute the first order condition, that is the derivative of this Lagrangian function with respect to xi, and so for xi. And you have to do it on your own. You know how to do it because you had your micro classes, and I know that you know how to do it. So you have to do it, and you have to derive the particular first order condition to get the solution for xi. And if you are successful in doing this, you will get that xi is this particular function. So it's an increasing function of theta, a decreasing function of pi, which makes sense because the larger the price of a good, the smaller the demand for this good. And you have this lambda multiplier here in the function as well. Remember that theta is between 0 and 1, okay? So that this is a positive number here in the power, okay? So there is a positive and negative relation between p and x. Fair enough. Hope that you are able to derive it on your own. Then you can use the budget constraint, which is this one, right? And substitute for xi to solve for lambda. So if you substitute this xi into this integral over here, assuming that all the varieties are symmetric, okay, which means that in fact the integral from this particular form can be written in a symmetric form, n number of varieties times pi times xi, and of course we know that this has to be equal to w, right? Because all the allocations with strict inequality are inefficient. Yeah? So you can write down this integral in that way, so that all the varieties are symmetric. You plug in the x and you solve for lambda for a given p, and you get something which is close to this, right? Hopefully you will do it on your own. Then when you have lambda, you go back to your x equation and substitute for lambda. Lambda is now a function of prices, capital N, which is the number of firms or the number of varieties, the same thing, and W. And you just get this very simple expression for the total demand for one particular variety, which is your income, your wage, divided by the number of varieties times the particular price of a particular variety, which means that if the price of a variety goes up, you consume less of this particular variety. Fair enough. So we have our consumer decision solved. Now, the second part of the Krugman's model is the firm's decision. So what about the firms which are monopolistic and competitive? We know two things about those firms. First of all, they want to maximize their profit. The profit function, which is exactly the one that we put in one of the previous slides, which is the difference in price of a particular variety minus the wage cost, which is the variable cost of production, times the number of units that each consumer is consuming of a particular variety I, times L. And L is the number of all the consumers in the country or in the market in which the firm is selling its price. It's an indicator of the size of the market, okay? But we have to take it into consideration because the firm is selling the goods in a particular market. But don't remember about this part on the right hand side here. This is the fixed cost of production. F units of labor have to be devoted to start production, and the cost of this fixed cost, or to put it differently, the unit cost of this fixed cost is the wage of the workers that has to be paid to those guys who are paying them, who are giving services to cover the fixed cost of entry. All right, so this is the fixed cost of entry in monetary terms. So this is the first thing that we know about our monopolistic competitive firms, that they are maximizing this profit, but maximizing it with respect to prices. Remember that firms are monopolists. They set the price of each and every particular variety of the good. Fair enough. Moreover, they're monopolists and they are also considering the fact that they know what is the actual function of the demand for their goods. This is what we assumed as well. Firms know the demand, producers know consumers' demand and set the prices. This is exactly what you have to take into consideration as well. And firms maximize this profit with respect to our constraint that they know the demand function for their good. So how to solve it? Simply compute the first order condition of the profit with respect to price, equalize it to 0, and remember to substitute for this xi. Xi is now also a function of p, and firms know it. So we have to substitute this function over here, compute the first order condition with respect to price, and solve for the price. You have to do it on your own. If you are successful, you arrive at a very simple equation that tells you that prices are actually the function of the unit cost of production, which is in our case only the labor cost, the wage, over this theta parameter that comes from our utility function, which tells us what's the level of differentiation between different varieties. Once again, remember, if theta is close to 1, this means that there is almost no differentiation between the goods. Goods are very close substitutes, which means that the prices are equal, very much close to W, right? And the firms have no big monopolistic power. In fact, the production sector is very close to perfect competition, and exactly this is the case. You know what's happening in the perfect competition, that prices are actually equal to W, equal to unit costs of production. And this is actually the perfect competition model. But now when theta is below 1, and if it goes to 0 in the extreme, when products are really differentiated between each other, they are imperfect substitutes, even complements. People want to consume different varieties of the consumption good. Now look what's happening with the prices set by firms. Well, the prices are way higher than the unit costs. If theta goes to 0, prices go to infinity, which means that the monopolistic power of the firms is going to infinity. Firms can set any price, and they know that they will find consumers for their goods because people want to consume all the varieties in the economy. All right, perfect. So we have the firm's decision done, and we have the price, the optimal price that is going to be the market price set by the firms. Very good. So now we can go back to our utility function and say something more about the utility in the equilibrium of the Krugman's model. What is the utility? Well, we know that the utility is simply this integral over here. Okay, I have it here. Yeah, I already put the utility function, which is this. And we can compute the utility function in the case of a symmetric let me just put the equation down. In the case of symmetric varieties, okay, so it's something like this. So instead of integral, we just take n times the number of all the varieties, all right? We substitute for our xi, which we computed in one of the stages above. And then we have that xi is w over n times p, which means that we can still simplify this equation. For p, we can put the price that we computed in the step above, which was w over theta, all right? So we have something like this. As you see, as you perfectly see, what will happen is that w's will cancel out in this particular equation. So we are left with an equation where theta is in the numerator and n is in the denominator. Don't forget about the capital N here in the beginning, all right? Because we have the sum over all the varieties. And here we still have the power, which is theta. All right, so now we can still simplify things. So we can put theta power theta in the front, and we can simplify with respect to n, and we have the power 1 minus theta, right? This is the total optimal equilibrium utility of every individual in the economy. What is important here? First of all, it depends, of course, on theta, on the parameter that that describes individual utilities. You know, the interpretation of theta, all right? But it also depends on capital N. What is the capital N? N is the number of firms in the economy, which is equivalent to the number of varieties. And the power is 1 minus theta, which is always positive, due to our assumption, which means that the more varieties you have in the economy, the higher the optimal utility of an individual. Why? Because people reveal love of variety. They want to consume different varieties, and the more varieties there are, the higher the utility. Once more, let's go to analyzing those two extreme cases of theta. If theta is equal to 1, we are in perfect competition, prices are equal to wages, varieties are perfect, almost perfect substitutes, and you see that the utility is not depending at all on the number of varieties. 1 minus 1 gives you 0, n power 0 is always 1, this is a constant, and utility is equal theta power theta is equal to 1, it's constant. It does not depend on varieties. Conversely, when theta goes to 0, which means we are in a very monopolistic world in which prices are very high, because firms have a very strong monopolistic power due to the strong love of variety of consumers, because people want to consume different varieties. In this case, the utility becomes almost linear in the number of varieties. Theta is close to 0, so you have theta power theta times n, which means that the marginal change in the utility in terms of the number of varieties is really big, right? But still, this is not the final equilibrium of the model. We still have one variable that is not well defined in the model, this capital N. How should we know how many firms are there in this monopolistically competitive model? There's still one condition that we didn't use in our model, which is the free entry condition. That is the fact that even though there are fixed costs of entering each and every the production sector, firms can freely choose whether they want to produce or not. So that this is something which relates this model to the perfect competition and causes that the profit in the equilibrium is going to be 0. If it was not the case, there would be still firms that would be willing to enter the market if there are positive profits to gain from producing different varieties of goods. If the profits were negative in the equilibrium, this would mean that some firms will have to quit the market, leave the market, and this would reduce the supply of goods and profits will go back up. The equilibrium level of profits for all the firms, as in the perfectly competitive market, is actually 0, all right? And this 0 profit condition, or the free entry condition, which we write down as, on the left-hand side, the profits equal to 0, will give us the equilibrium number of firms. All right? So what do we have to do here? It's simply to substitute for x. We know that x would be equal to, the left-hand side would be equal to pi times w. And instead of x, we simply write the equilibrium x from the consumer side, which is n w over npi. All right, correct. Just checking this is correct. It looks that this is correct. Times L minus WF, and this is equal to 0. All right, what next? Now we know something about the W. We know that W, in fact, is theta times P, right? We use this equation, and we substitute, for W, we substitute theta times P. All right, here we have theta times P as well. This is divided by NPI, and this is equal, this is equal to WF. Fantastic. So now you see that some things will cancel out, which is always something that you want to see in the model. All right. You know what? I don't have to substitute here for this W because we have W on the right hand side as well. So we will cancel out the W. So this W with this W, and we will cancel out the P's. Okay. So we will be left with 1 minus theta in the numerator, and in the denominator equal to f. Remember that both theta and f are the parameters of the model, which means that we have the equation for our endogenous level of firms. There is one thing that I forgot to write here, which is the capital L, which is here on the left-hand side, and it's here on the left-hand side as well. But it doesn't prevent us from writing down the equation for L, which is 1 minus theta times L over F. All right, if you do the very simple algebra. And this is exactly what we have over here. Once again, what's the economic interpretation of this equation? The equilibrium number of firms is proportional to the scale of the economy. That is the number of consumers in the economy, and it's increasing in the scale of the economy. It is decreasing in the fixed cost of entry, which means that the larger the fixed cost of entry, the lower the number of firms in the equilibrium. And it's also dependent on this 1 minus theta. Once again, if we are in the perfect in a model which is very close to perfect competition, theta close to 1, there are almost no firms. Well, this goes to 0. While when we have a situation in which theta goes to 0, imperfect competition, monopolistic competition, then this 1 minus theta goes to 1. And the final thing we can compute is the final utility function, which can be computed from the initial utility function, this one, substituting for n. All right. And what you see here is that the final utility is actually the function of this market size of the economy, which is a function of the size of the economy. And this is the main feature of the Krugman's model, that your final utility from consumption is a function of the market size effect. The larger the country, the larger number of varieties, the more you are happy in living in this country. This is the main prediction of the Krugman's model. All right, so this was a bit of repetition of your micro class. Now let's go to the trade class. So now what's happening in the Krugman's model when there is trade? When there is trade, well, each of the two countries that or all the other countries that we can have in the system, economic system, will trade its varieties. Those countries will produce different varieties while there are different firms in different countries, which means that the new utility function will be the sum of the varieties from the home country plus the sum of the utility that comes from varieties from the foreign country, which we index from n plus 1 to n star, let's say. In principle, there will be more varieties that are going to be available in the home country when the country opens up to trade. This means that the utility of the consumption of all the individuals will go up. Why? Because people will choose now to consume more goods, so more varieties of a good, but in smaller quantities. And you remember what this makes, why this is, how this is motivated. With the strictly concave utility function, you want to consume different varieties in small quantities. Therefore, this would be the new quantity of consumption of each and every variety in the new equilibrium with trade, n plus m star, and this would be the new utility, the new value of utility when the country opens up to trade. And you see, this is necessarily bigger than what we had before in the autarky when we considered only the country, because n star is a positive number. Okay. Note that this is true in the Krugman's model, even though the wages, incomes, GDPs are not changed. We say nothing about technology differences between countries. We say nothing about the endowments in terms of the factors of production between countries. We abstract from everything here. The only motivation for international trade in the Krugman's model is the fact that people have different preferences. We are different. We like different things. And since opening up to trade increases the actual number of varieties of consumption goods that we have access to, that is why we gain from trade in this particular model as a consumption externality, as a very simple consumption externality in the monopolistic competitive model of the economy. To some extent, it goes back to what we said in the specific factors model. There also the gains from trade were due to the fact that the economy had an access to different combination of consumption goods. But there the motivation was different. Okay, there the motivation was that the production technology was strictly concave. Here the motivation is that the utility function is strictly concave, and the fact that people like to consume different types of consumption goods. All right. Okay, so I think this is the end of the Krugman's model. Hopefully that you get the intuition and you are able to derive the intuition of the Krugman's model that the utility matters. The access to different types of good matters as long as people differentiate between the goods. So to finish up with the lecture today, I'm already 1 hour of talking, so I will be very brief. We go back to the comparative advantage models. We go back to the Ricardian trade models, which were in fact which were not that popular at all until very recently. Why? Because they were not mathematically tractable. It is, with a too good two country model, Ricardian model, as we analyzed before. Well, it was quite simple. But then what happens if you have many countries, many goods, many factors of production? Those models become untractable. This is a big disadvantage of this Ricardian trade motivation, Ricardian motivation for international trade. But now, after one seminal paper by Jonathan Eaton and Samuel Kortum in 2002 Econometrica, well, actually, the Ricardian trade models are really flourishing right now because those guys managed to solve the Ricardian trade model with a very nice trick, mathematical trick, which I will not introduce to you right now. I will just give you the main intuition because, in fact, those types of models are now state of the art. They are really the most advanced models that you have out there in the literature. This is really, the frontier of the economic research, using those models of comparative advantage with multiple sectors, multiple countries, multiple types of goods. So what is the trick here? The trick is that they are using stochastic calculus. So they are assuming that the productivity is distributed according to a certain distribution. So the productivity of producing a particular good in a particular country is a random variable. Hopefully you know what's the product probability distribution. Hopefully you know what's the random variable from your statistic classes. But this is a very simple solution of this tractability problem of the Ricardian trade models. And they managed to develop such a model that is based on comparative advantage using a bit more advanced mathematics than before. So I have here some slides that describe the main basics of this Eaton-Kortum model. I don't want to introduce it to you because I tell you, it really goes beyond what is required from undergraduate students in the macro class. In fact, analyzing such type of a model would and quantifying it and doing some policy experiments with this type of model would be a fantastic master thesis. So if you are interested in those topics in international trade, in international economics, I really advise you to read about those new comparative advantage trade models, which come from this particular paper by Eaton and Kortum. If you advance a bit more on those type of models, I'm pretty sure you can write your PhD in economics very easily with those type of models. As I told you, this is the frontier of the economic research at the moment. What is specific about this Eaton and Kortum model is that they managed to model the production technology using a probability distribution. And this is a very specific probability distribution, which is called the Frechet distribution of probability, which is characterized by two parameters. One parameter, which is responsible for absolute advantage of the economies, which is simply the level of technology of the country, which is responsible for the location of the distribution of productivity. You know what's the location of the distribution, the mean of the distribution, right? But there's also a second parameter of this Frechet distribution, which is even more important from the perspective of this particular trade model, theta, that governs the variation in productivity across different goods and governs the comparative advantage between economies in producing particular varieties of goods. And this theta is nothing else but the standard deviation, the dispersion of the distribution. So not the location. The location is here with this parameter t. Theta is describing the dispersion of this particular probability distribution. And you have your absolute versus comparative advantage model. What matters for international trade is exactly this comparative advantage. And we go back to what David Ricardo talked about in 19th century. This is a very neat and elegant and beautiful way of describing the idea of David Ricardo in a very elegant mathematical way and tractable way. Mathematically tractable, that you can solve for the equilibrium easily, you can calibrate this model easily, you can simulate different counterfactual scenarios, you can run regressions, okay? What is specific, the last note on the Eaton and Kortum model, what is specific about this particular Frechet distribution of probability? You might have not heard about this. You know the normal distribution, the Gaussian distribution, you maybe know the uniform distribution of probability, you know the Pareto distribution, you know the t-student distribution, but you might never heard about the Frechet distribution. So what is specific about this Frechet distribution? Well, it is a member of the so-called extreme value distribution class. In line with Weibull distribution, Gumbel distribution, this Frechet distribution has very specific feature, which is fundamental in economics in general. It means that this distribution, just as all the other extreme values distributions, they are max stable. What does it mean? Well, it means that the maximum of a random variable, which is Frechet, put it differently, the maximum of random variables which are Frechet, so if you have a maximum of x1, x2, x3, x4, and so on, xn, all of the x's are Frechet distributions. This maximum itself is also a Frechet distribution. And this is a fantastic property of this particular distribution because it simplifies all the algebra, all the computations, because what we are interested in is the comparative advantage, is the country which is capable of producing a particular good omega with the minimal price. And the price is a stochastic variable. And this means we have a very nice statistical device that allows us to describe the distribution of this minimum, maximum, which is minus minimum, the minimum of those prices. And voila, it really easily solves our trade model. I will not go deeper into this. If you are interested in this, you have still time to learn about those type of models. You are very much um, welcome to deepen your knowledge about those super new types of trade models. And I tell you, if you want to have a very sexy subject for your master thesis, go ahead. If you're interested in international trade and international economics in general, go ahead and try to fight with this. This is a very very pleasant model to analyze. All right. So to sum up this whole lecture, the state-of-the-art models, including those new comparative advantage models, also add some other features of the modeling device, like heterogeneous firms, so firms of different size, different productivity, different types of products. There are also models with heterogeneous individuals, people of different skill level, of different occupation. There are models with tradable and non-tradable goods. This goes back to the terms of trade definition we had before. Labor market effects of trade in general equilibrium. So not only the goods market, but also the labor market is modeled within one particular big model. And what is also related to this is that there is a literature that relates workers' trade, general trade of goods and the production side of the economy with workers sorting across countries and sectors, endogenous migration. And this is explicitly what I'm doing in my particular research in my research life. These are the type of models that I'm doing, and I'm very close in what I'm doing to those models by Itum Kortum. I also worked on models of Krugman, and but I'm doing it more from the side of international migration, not international trade, even though I also did some stuff in international trade. Whatever, okay? Summary of the big lecture about the introduction to international trade. After this lecture, I really hope that you have a very good idea what are the economic motivations for international trade, plus you know how to formalize them in a formal mathematical model. First and most important motive for international trade, comparative advantage of economies. And we have two different types of comparative advantage due to allocation of specific resources. This is the Heckscher and Olli model. No mathematics in this model. I didn't present it to you, just the intuition of the model. The second type of comparative advantage, which arises from the levels of technology. And this is the Ricardo model with two sectors, two goods, one factor of production, very simple model, which we solved with some numbers. And then the Eaton-Kortum model with many countries, many sectors, many goods. And this a bit more advanced, but super sexy and super nice way of describing the race of comparative advantage in international goods market. This is the first motivation for international trade, comparative advantage, not the absolute advantage, comparative advantage. Remember, this is very important for the exam. Second thing, increasing the choice sets from the specific factors model and from the Krugman's model as well. The fact that people can consume now different bundles of goods that are different from the goods that are produced in a particular country. So the exchange of goods is something that is good for the economy in general. Either it is due to the fact that there are decreasing returns to production, this is the specific factors model, or due to the love of variety, the decreasing marginal utility of consuming the same variety of the goods, all right? So increasing the choice set can have a broader meaning. And the last thing, the last motivation for international trade across countries are, of course, the economies of scale. It is profitable for firms to enlarge the markets, to have larger sales by specializing in a particular variety of the consumption good. And if people differentiate between different goods, this brings even more gains from economies of scale due to this love of variety, externality of consumption that we analyzed in the Krugman model. So you see, these are the main motives for international trade that are out there in the economic literature, and I hope this is clear for you in terms of how to motivate them and how to describe them. All right, as usual, some focus for the exam, comparative versus absolute advantage, gains from trade with mobile and mobile factors, Leontief paradox, what's it about and how it was solved, and the concept of economies of scale and love for variety. I'm pretty sure you don't have to know how to derive the exact Krugman's model at the exam, but you have to know what is the economic interpretation of each and every equation of the model. And for this, you need to know where it comes from. So it's always good to know what is the micro foundation of all of those equations that we see there and how to derive them. This gives you some more economic interpretation. For today, that's all. So I hope that you enjoyed the lecture and enjoyed the lecture. We see each other next week with the policy-oriented lecture, which hopefully will be quite interesting because I would like to focus on three important things that are kind of important from the point of view of the course, but also the actual situation in the world. We will talk about the currency crisis. We will talk about the impact of trade tariffs for welfare and in general for well-being of the economies. And we will talk about the COVID crisis. Hopefully, I will be able to provide you some particular numbers, but I will not spoil this next lecture. Hopefully, I will be able to give you some nice evaluations of the lockdown and of the general economic situation after the crisis, within the crisis, the COVID crisis in Luxembourg. So see you next week and stay safe.